What is going on, guys? And welcome back. Welcome back to the um, very seldom streamed Cloudology channel. So, as you can tell by the very obvious clickbait thumbnail, very good thumbnail, however, um, we're going to be building a Minecraft server today, but we're going to do it in a way where it's kind of automated. So, this is the Learn to Cloud series, which I directly ripped off from Tech Chief with his Learn to Code Live. This is Learn to Cloud Live. And basically, my intent with this series is to build stuff that I want to build as far as like a cloud engineering perspective, right? So essentially, what I want to do is I want to start with a project. So in this instance, we're doing a Minecraft server, but in like today, we're going to get you set up with like a deployable Minecraft server, like an MVP, right? An environment MVP. It's actually going to be functional, so which I will demonstrate. But what I would like to do is continue this series and then add more components to our current Minecraft environment or whatever else thing that we're building, right? So we could add like way more automation in the future. We could add like logging and monitoring, and we could do alerting even. I don't know if like the Minecraft server goes down or whatever. We can handle IAM better than we're going to handle today, but I'm going to keep these relatively short. We'll see about that, but essentially I've got most of it worked out right now. We're gonna have to do a couple tweaks live because I want to spin up a different server than I actually started with, but we can go ahead and get started, and I will share my screen over here. So we're starting off in VS Code, just in our Minecraft bedrock server. I'm going to do Minecraft bedrock edition, so it's cross-platform. And we're going to go into GitHub Cloudology Minecraft. Okay, this isn't a Git repository yet. I will make it a Git repository. But so essentially the overview of this is I want to do this all with Terraform. So I want to do this in an automated deployment fashion for right now. And then maybe later on we can work on like, dude, even moving this up to like Kubernetes or something like that. And, trying different deployment strategies to get it on to migrate it to Kubernetes. But we'll save that for later. And for right now, we're just going to use Terraform. And I've got a couple functions. 2 out of 3 work. So full disclosure, this comes from a tutorial for Google, which after the stream, I will put that link in the description. However, that tutorial was completely wrong, and I had to rewrite all of their cloud functions because I'm sure that article is extremely old. So the first thing we're going to do here is we're going to make some directories. We're going to make our modules directory. We're going to make a functions directory. And we're going to make a, let's do a main.tf. We're going to do a state.tf. We can store our state objects, and we're going to make a variables file. And really quick, just on the explanation behind why my directory structure is like this. So I created my own module, I kind of like stole Google's module and created my own module to kind of fit our needs. And this is just like I guess a Terraform best practice, where typically if you want to, let's say we're in a larger, company, right? And we use a lot of the same Terraform modules or the same Terraform code over and over again. Well, modules help you kind of like consolidate that code and only run like very short snippets that will deploy your application, right? or deploy whatever infrastructure you need. And then if we go into the modules directory, we're going to need a couple folders as well. We're going to need a cloud function, make directory. So I actually have all this coded out. I just wanted to code it kind of live for you. I'm just going to copy and paste a lot of the code, and then I'll explain it later. What is up, Christian Soto? I see your comment. And let's see. Cairo? I'm sorry. I'm going to butcher that name. But what's up, Christian Soto? What's up, guys? Thank you for commenting. So in modules, we're going to make a directory called cloud function. Function. There we go. And then make dir GCE container. Okay, so if we expand our little modules directory, up here you can see we have 2 more empty directories, right? And that's where our modules or our templated Terraform code is going to live, right? So we'll start off. Let's go to cloud functions or cloud function, and then we'll do touch gcf.tf, and then we'll pop it in this file. And again, this is a module I kind of created myself. So I'll just kind of like go over it briefly here. So without going too crazy, right? Without going too far down the rabbit hole, Terraform uses what are called resources, which basically correlate to resources you would use in a cloud platform, right? So a resource, for example, would be a Google Cloud Function or a Google Compute engine, right? So if you've seen my other Terraform videos, you'll probably understand that a little bit better. But this module essentially, what it is we're creating a Google storage bucket to actually store the source code for the cloud function, right? And then we're creating the actual cloud function, and then we're referencing our storage bucket above that we just created, right? And then we also added an IAM member. So basically what that's going to do is allow these functions to be ran by anybody over any protocol, like HTTPS, whatever. Real quick, let me check my network. I'm going to sign into my other network because I can see my network dropping, so I might drop out for like a second here. All right. I think I'm back. I hope I'm back. Yes, I'm back now. Okay. So, like I said, this is essentially going to allow anyone to run our functions for right now. Next thing we're going to need is we're going to need a variables file that are specific to our module. So you can see how we've got some names here like variables, object name, bucket name, function path, stuff like that. That is going to be defined in this variables file. So we're going to do touch variables.tf here. And again, I'm going to copy all of this into here. So here we're just setting our variables. I know they're empty right now, but that's because we want to set them where we're actually calling the module, which I'll show you that in a second. So let's go into our GCE, which stands for Google Compute Engine container. So this is a module I kind of like made myself / didn't. And I'll show you what I mean right there. And we're going to do touch GCE with container.tf. And we're going to do variables again, because different modules need different variables. And I'm going to grab my code from over here and place it here. Okay, so this is going to be a little bit hard coded. So granted, this is a little bit if you're doing this like professionally in a company, I probably would not do it exactly like this. So this module is actually from, excuse me, why can I not highlight? So this module right here, this module GCE container, is actually coming from another repository that was published by Google, right? So I am pulling that in to my module and making it work for what I'm doing, right? And basically what it's doing is it's creating a Google Compute Engine server, so VM, that runs a container, which surprisingly Terraform doesn't have its own like provider for or option. So kind of had to make our own module for that. And what we're doing here is we're setting some environment variables. We're setting security contexts, which we're not doing privilege mode for the container because that's very bad security practice and you shouldn't do that. But we're specifying a port. We're specifying an image. And we're specifying a custom command if we need it. I don't think we're using it for this one, actually. But we're also specifying a volume mount. And the reason why we're specifying a volume mount is because we need to save our Minecraft world, right? So it needs to get saved somewhere. So naturally, containers are kind of stateless. So you want some kind of like mirroring to the actual host system, like file system, right? So we want to save our volume, which I called MC data. And essentially, this is going to have storage for our container, right? Here is our actual compute instance. So I'm just doing a N1 standard one. The name of it's going to be server one. We have our project ID, our zone. So our boot disk. So it's actually going to be the source image for the container, which we'll get to later. We'll get to when we actually instantiate the module. And then we're going to give it a network tag of Minecraft server. And this is so we can essentially create our firewall rules that will allow us to basically access our Minecraft server on the correct port, right? Now, we need our variables, which I have just off screen over here. I realized actually coding live, like this would have taken me absolutely forever. This probably would have been like a 6-hour stream. So the instance name I hard coded just because we're using it in our cloud functions. Again, this is an iterative process. So maybe if we want to be really cool, we will be able to grab that name from, Terraform outputs or anything like that. But we'll do that a little bit later, right? So now what we're going to do is we're going to go into our functions directory. And we're going to create 3 directories in our functions directory. Functions, and we're going to make directory. We're going to do an add user, which full disclosure, this function is not going to work correctly yet. I still need to figure out. I'll explain when we get there. And then we're going to do start server, and we're going to do stop server. So the intent behind these functions, and these are JavaScript functions, unfortunately. But what we're going to do is we're going to add. We can add our functions here just for visibility's sake, right? So I'm actually just going to copy. So we're going to do add user, and we're going to do add-user.js. And we're going to copy that right here. Or actually, we're going to copy into add user. And then we're going to do the same thing for our package.json that is also in there. And we're going to do the same thing for our zip file. So I realized that Terraform has a built-in function that will compress files for you, right? However, when I was doing this on my own, for whatever reason, when I zipped that directory, Cloud Functions really did not like that. So it didn't like the directory structure. So what I did is I just zipped the file myself. And essentially, here we have this is essentially what our function is going to be doing. So my intent behind this was if you wanted to have a friend be added to the firewall rule that we're going to create in order to start the server, right? Or run the server or allow you to get to the server, right? So let's say you have friends. Let's say in this world, somehow you have friends, right? And you want them to join your Minecraft server. Well, this function was supposed to add their IPv4 address to the firewall rule. However, I found out that Node actually uses IPv6 instead of IPv4. So when any request is sent, my intention was to grab the user's or the caller of the function's IP address when they call this function and then enter it into my firewall, right? Using the code that's listed here. And I'll put all this on GitHub after the stream is over, right? Yes. Imagine if we had friends, guys. Imagine that. So we're, this is a made up scenario, but here we are, right? So anyway, it needs an IPv4 address in order to do it, but I have no way to get it that I've figured out yet. So this function doesn't work, but I'm still going to include it here because I want to make it work. We might have to refactor to Python, but we'll focus on that later. And now essentially we're going to do the exact same thing for our start server, right? So we're going to do Minecraft functions start server and then start start server.js, and then we're going to do here. I not have a start server in here. I definitely do. I see it. I sees it. Why is my autocomplete not working? String not in pwd. What is happening here? Okay. Oh, cd. Duh. Why did you guys tell me? I'm using the wrong command. cp. Sweet. Thank you, sir, if you watched from the beginning. So this will give you a functioning Minecraft server, but there are some parts we need to flesh out in later parts. All right. Like I said, this is an iterative process on making this into like a more automated environment. So we'll get there. We will get there. We're going to grab the zip file over here, and we're also going to grab our package.json. So I should note, Cloud Functions is kind of weird. I had actually never worked with Cloud Functions before I started doing this, right? It's not something I commonly work with. And it's very weird how it wants every function needs its own package.json, right? So it's going to be kind of weird. I don't like that, but it is what it is. All right, so let's go over our start server function. This actually does work, so I can show you this. So I had to rewrite this function to actually get it to work correctly compared to the tutorial that I was looking at. So I hard coded a lot of the values in here because I knew where I was going to deploy all this stuff, right? So I hard coded the zone, the project, the instance name, and the firewall name that I'm going to be using. So for this example, we're going to be using the default network. Don't ever use the default network. Create your own networks, create your own, subnets and firewall rules and stuff like that. But for simplicity's sake, I'm using the default network right now. Quick overview. Essentially, we're using the Google Cloud Compute API via JavaScript. So we're using like a library that grabs compute information, uses application default credentials for Google, right? So what you're going to do, or what this function does, is it grabs the server IP. It's going to check if the server's ready, and then it's going to wait for the server to be ready, essentially. So without getting too far into the code itself, which is not, it's not complicated code, it's not hard. Just in the sake of time, I'm trying to keep these a little bit short. So in order for Cloud Functions to run, you actually need to export the function, the one function that you want to run correctly. So we're just going to export our start instance, which is going to be an asynchronous function. So essentially, this checks the server status, and if the server's already running, it's not going to try to start the server again, right? However, if it's not, it's going to start the VM, and it's going to check to see if it's ready. And then once it's ready, also, this doesn't work either yet. So again, this is where I was talking about like Node using IPv6 instead of IPv4. I still need to figure out a solution for that. But what it's going to do is it's going to add my local IP address, which is going to change. I actually need to see what that is. It's going to be this IP address right here. I'm going to copy that, and I'm going to place that right there. Okay, which actually I'm going to need to rezip this file now. There's a lot going on. So when I first did this tutorial, I did this with Minecraft Java edition, right? So that's the Minecraft version I was used to playing on the computer, right? But Bedrock edition uses a different port, which I actually need to look for right now. We're going to look for this. Learn to Google Live. Minecraft Bedrock default, or actually, let's do this Docker image because we're going to need that anyway. Boom. Okay, so right here is our default port for Minecraft Bedrock. So we need to change that. This needs to be an ingress, and we need to set our server tags, so our network tags. And then it's going to create a firewall rule. It's supposed to send this. It actually doesn't because I'm sending a status somewhere else before. It actually might work now, but I think I fixed that. Anyway, it's essentially going to give you this IP address and a port, which I realize I need to change this. So yeah, we're going to have to rezip all of this and do it again. I'll actually show you how to test the functions locally as well. But let's do stop server next. Because I need to get all these functions in here. Server, so let's grab the package JSON, and we'll grab the stop-server.js, and then we'll grab the compress file. Alrighty. So we go into stop server. And what I mean by package JSON being different in each one, so essentially you need to set the actual main function in each individual package.json, right? So here you can see our main function is start-server.js, and this lives in the start server directory. And then we have the add-user.js in our main here, and then stop-server.js. So that's very important. Your functions will not work if you don't do that. So I'm gonna be honest, like I like Google, but I think Cloud Functions is terrible, and AWS Lambda is much better in my opinion. But you know what they say about opinions. Now let's look at our stop server. Again, this is doing essentially the exact opposite of what start server is using. The only thing it doesn't do right now is it doesn't clean up the firewall rules, right? So this essentially just stops the server using the JSON or the JavaScript library that we've been using. Okay, so we've got our modules set up, I believe. Now we need our actual main function that's going to work, right? So we're going to have to tweak it a little bit, like I said, since I'm using a different version, right? So essentially we got to set our provider up here, and that's just telling Terraform where to build all this stuff, right? Here's our module that gets imported from our modules folder up here. And so we have our zone, which I have in a variables file over here, which we'll grab those right now, actually. And I'll throw this over here. So this is just setting the zone, the region, the project, and the Terraform service account. So that's kind of important. So here this is where we're gonna need our other Docker image. So we're gonna need this guy right here. This is just the image name, and we're gonna throw that right there. So it's gonna be a little bit different. Environment variables, you want to make sure that this EULA is just the user agreement is set to true. That way it actually like starts up, and then ops basically sets the server admin, right? I think there are other variables we may need. Let's look at some of these examples here. I think it actually shows you a Docker file. Yeah, so we want game mode. We can do game mode. From auto format. So we want survival. If right. And then difficulty normal. Because we're not super sweaty Minecraft players, right? Let's into a string. Okay. So here's our instance name. That's going to hard code the name to MC server dash v1. Network, like I said, we're just running on the default network and the default subnet. If you're doing this in a production capacity, I recommend creating another resource, which is a VPC and then a subnet, and doing it the best practices way. This is not the best practice. This is just an example that I can live stream quickly, relatively quickly. So now we have our other module, our cloud function module, and essentially this just points to where everything is. So this is our bucket name that gets created for all the functions, and this is the module source, and then we have our actual compressed file. So in order to send files to Google Cloud for like storage objects, typically you want to compress them so they're not super huge, right? And that's what we're doing here. And like I said, I know Terraform has a built-in like zip function, but it doesn't work very well with Cloud Functions. So this is essentially where our function lives, and then this is going to be our function name. For whatever reason, it can only be a certain length, so I had to cut out the A. So I did. Description, and then our entry point, which is important. This is going to be the function that you exported in your actual JavaScript code. So remember, we exported that start instance. This is where we identify it, and we're going to do that 3 times for each function, right? Oh, also, we need to change this port to our bedrock server default port, which you can run it on whatever port you want. This is just so we have that. One thing we will actually need to change, I just remembered. We need to change this to UDP, since Bedrock server does not use TCP protocol, it uses UDP protocol. I won't get into different protocols, but essentially TCP is like normal web traffic, port 443, port 80, port 22. UDP is something a little bit different. It's just a different protocol for essentially the same thing. And then what did I have the state file there for? Oh, I think I was going to move the state to Google Cloud, but we'll focus on that later. Again, iterative process, right? So there is one thing that we should do before. So, well, I guess we can do this. We can initialize this directory, right? So we can do terraform init This is essentially just going to download all of our modules and make sure Terraform's pointing at the right thing. And then we can actually run a Terraform plan. I'm kind of curious to make sure that, okay, yeah, 10 to add. So hold on, we're almost there, but we need to change some things. Basically, we need to rezip this start server. So essentially, because we made changes in here, this is the downside of like manually zipping the files and not using the Terraform tool, right? So the problem with this is that every time we want to make changes to these functions, we have to rezip the files and do them again. So in the next video, we might clean some of that up, and I might figure out why Cloud Functions doesn't like the directory structure that I have going on, and we can change that a little bit later. But for right now, I know this works, so let's go to functions. We need to go to start server. Make sure we're in here. We're gonna rm-rf start server.zip, and then we're gonna zip, and we're gonna call this the same thing. Zip, and then we're gonna zip start server.js and our package.json. And it's going to compress those files and create a new zip file. So again, there's a better way to do this. I just couldn't get it to work as I wanted it to yet. So let's go to Minecraft Bedrock here. And I think we're ready to apply. I believe we're ready to apply. Let's see. We're going to find out. That's for sure. So the only thing is, like, I don't know if I haven't actually used this image, this container image yet. So we'll see if we need to add anything else. Oh, privilege mode true. Why is privilege mode true? We shouldn't do that. We're going to leave that for right now, but don't run containers in privilege mode, guys. So this is like a do as I say, not as I do type situation, which I don't like doing, but it is what it is. Let's run and apply. Let's do another plan. All right. 10 to add, and then do Terraform apply. So ideally, we can add this and apply it, and this is just going to work. In a perfect world, this will actually work correctly. So the VM takes a little bit to create. The functions also take quite a while to create. And then if we did the functions correctly, which I didn't test them, which I definitely should have, there's a way to test them locally. I'll actually show you the command if I can. 3 rep npx. Yeah, yes. So let's grab this right here. And while this is running, we'll open a new terminal. But if we go to functions and let's do add user, since I know it doesn't work. So this is essentially going to test our function locally to see if it actually runs, or if it's going to run in Google Cloud Functions, right? And essentially, it's just going to file up, I didn't do an npm install. So npm install is essentially just going to load the function and verify that it works before you actually push it to Google Cloud. But I think it's still going to work. So you can see here, it's actually running locally. And then if we click that link, it's going to run our, actually, if we just go to our browser, we'll just do this. We'll just do localhost 8080. You can see firewall were created, and that's the problem I'm having. So let me explain it to you right here really quick. So because we need an IPv4 address to add to the CIDR range of the firewall rule that we have created, right? The problem is we're using IPv6, or Node is using IPv6 for whatever reason. I don't know when that changed. It used to be IPv4. Apparently that changed after a certain version, but I digress. We will figure it out eventually. It looks like our apply actually completed. We verified our function worked locally. And now let's take a look on our Google Cloud Console. And we can see we have our MC server v1 here. And let's actually just look at these logs. And let's make sure that these work correctly. So essentially, this is the container logs, right, or the VM logs. And essentially, what I want to do is make sure that this is actually working correctly, because I haven't tested this image. So we're doing new image. It looks like it was able to pull the image, so that's good. Now I just need to see if it actually started the container, which I think it did. Let's see. Let us see. So we do a screenshot? No. Details. Logging. There we go. There we go. Permission denied. Oh, it always logs me into my other account for whatever reason. My other Google account. So let's make sure that our server is actually running. I know this looks very confusing, and to be frank, it is pretty confusing. But create container. I think we should be okay. Yep. Basically, I'm just looking for any error messages from the container. But I think we're all right. I mean, we'll find out, right? We will certainly find out. So now what I'm actually going to do is let's go to back to our console. Let's go to our cloud functions. Cloud fun. And we're going to take a look at this start server function right here. So this is what we just uploaded. We'll check the source and make sure that our changes actually worked correctly. There should be a new port and a new IP, right, for the firewall role. Yeah, there's my IP, there's my port. Okay, so what we're going to do is we're going to trigger this function. And the way we do that is we have this trigger URL. And remember, anybody could run this. Again, we might want to lock down these permissions for some of these functions, at least for the start and stop server. That way people aren't like messing with your stuff, right? But once we figure out the add user, what we're going to be able to do is just send people that want to be added to the server this link, and it's going to basically spit out the server IP, and then it's going to spit out and it's going to create a firewall rule for them, so they're actually allowed to join. But let's kick this off. Server's already running, but I believe that it also should have created a firewall rule. That's just my bad coding practice right there. That's not like an actual failure. All right, so let's check our firewall rules and see if it actually got added. Firewall. Minecraft rule. Owner. It may have not been added. Okay, it was not. But I think that's because the server was started. So here's what we're going to do, actually. We're going to stop the server. We're going to go back to Cloud Functions. I'm going to open this in another tab. And again, that's the wrong profile. We're going to go to stop server, and that's going to bring our server down. So again, we need to clean this up, right? But when we stop the server, it's going to bring the server down. And then essentially what we're going to do, and we can verify that actually. I'll show you guys that it actually works. This way you don't get charged for just running a random server, because this will actually cost you like $80 a month to continue running like this. So the two most important functions are stop and start, right? The add user, we can add that manually, right? Or we can do it with Terraform. But we're going to wait till this stops, and then we're going to start it again. And that should add our new firewall rule, right? So we're going to trigger this guy again. Excellent. Yes. So here you can see Minecraft server started. You're now spending real money. IP address of the Minecraft server is that. Your IP address is, remember, we hard coded it in the function, so it works here. And then we also created a firewall rule, but let's verify that that firewall rule actually worked, because we kind of already had a firewall rule in place because I created it. I didn't have a cleanup function. All right. We'll work on that. Let's see. There might have been an error. Man, this is what it's like. Oh, memory limit exceeded. That's not good, but it did work, I think. Hold on. Let's see. Did it really create the firewall rule? It might have already had the firewall rule and then just said, oh, it existed, and then didn't create it. Oh, yeah, it already exists. Okay, so essentially it did work, but it tried to create it, and it already exists. So basically what I'm going to do is I'm going to edit this, and we're going to add my IP address. So this actually gives me a pretty good opportunity to explain side ranges. So if you just want one IP address to work, you need to use the /32 prefix. So if we take my IP address from up here, right? So curl IP info.io, grab this IP address. I'm actually just going to add this here because they're both my IP addresses. We need a 32. So that restricts it to only this IP address. If you did a range like 16, that will include like a whole bunch of IP addresses from that IP address. So it'll give you a range basically. We don't want that. We just want us to be able to access this for right now, right? All of that, and then we'll do a UDP port, which I believe is this 19132, and we'll add that right there. So those two ports, we actually don't need this anymore, so we can get rid of that, and we can save it. So now we should be able to actually play Minecraft on the server. So we tested both of our functions, and they both work, kind of, more or less. Again, we've got more cleanup to do, but that's for another episode. But let's make sure that we can actually connect to our Minecraft server. So we're going to copy this IP address, and you'll have to forgive me because I have never even started up Minecraft Bedrock Edition. So I don't know if this is going to take longer than it should, but ideally this should work correctly. So let's do installs. Oh no. We do Bedrock. Is there a Bedrock? I have for Windows, but it's not playable on this device. Okay. Can I even play Bedrock on Mac? Let's Google that. Minecraft Bedrock Mac. Here we go. Learn to research live. Oh, there's no official support for Mac OS. Well, that's problematic, guys. If we use Parallels, we can use it on a Windows virtual machine. Okay, so for the record, I probably should have made sure I could play Minecraft Bedrock Edition. However, we can still verify that this server is actually running correctly. And in part 2, I will figure out virtualization and actually join the Minecraft server. So my bad on that one. I definitely should have checked that before I started. But essentially what I want to know is, did this server run correctly? Which actually what we can do, I thought there was a way to look at logs just in the actual like console. Apparently not. So let's go to logging again. Basically, I just want to see if the server has started. That's what I'm looking for. And if it does, or if it did, so what's the latest? What time is it right now? 48. Okay. It looks like it's fine. Container exec start. Host, port, server port. Yeah. I think our Minecraft container is actually running. And I would love to show you by joining a Minecraft server, but apparently Minecraft Bedrock does not work on Mac, and I have to do a virtual machine. So I will look into that. But the lesson behind all of this, anyway, was that you actually can create a Minecraft server in an automated fashion. And like I said, part 2, we're going to figure out some of these bugs. I'm actually going to connect to the server. But these are all the resources right here. And actually, what I'm going to do is I'm going to commit this to GitHub pretty much right now. Sign in. I'm going to add this to my Common Sense Cloud account. That way you guys will have access to it. It's going to be a public repo, of course. Let me probably help if you guys would see what I'm doing. Okay. So we're going to create a new repo. We're going to do Minecraft Bedrock, right? TF code and cloud functions to oh, come on. To deploy Minecraft Bedrock server. Okay. Public. Not going to worry about a README. Yes, we're going to do a git ignore with Terraform. And actually, we're not. We're going to do none. None. No git ignore. We want an empty repo. No license for right now. We're going to do a creating repository. Push an existing repository from the command. This is what we want right here. Actually, we need to do this guy right here. And we'll go to our VS Code. And essentially, oh no, we need to do a gh login. Gh config login. Gh config login. No, what about list? Oh man, it's because I'm logged into my other account, man. Auth, gh auth. Gh auth login. There we go. GitHub.com. Yes. GPS. Yes. Web browser. There we go. We're going to copy this and do enter. Continue. Yes. Authorize GitHub. Sweet. So now we're logged in under Common Sense Cloud. Too many GitHub accounts, guys. Excellent. Git status. And what we're going to do, we need a new file. .git ignore. And we need to ignore to star.terraform. And then star.tf state. I believe. I think just .terraform will be fine. And we can also ignore our Terraform lock file. State. There we go. Boop, boop, doo, doo. And then let's ignore our .terraform, not lock. CL. Right. Yes. Okay. So it basically just ignores all of our sensitive stuff, right? So we do git status add git. Can I do remove terraform tf state? Okay, didn't match any files. Excellent. We're going to do initial commit. Yeah. Hopefully nothing crazy got added. This might actually take a little while to all node modules. Damn, that's what I forgot to ignore. That's unfortunate, but it is what it is. So it did not take that long. All right. Let's see what we got. Hopefully we didn't push our state up there. We didn't. We managed to not do that. Okay. So I will actually put this in the description after this stream is over, but I digress. For right now, we've got the baseline stuff handled, right? So we've got our infrastructure deployed, which you can also destroy using the Terraform destroy command. That way you don't use a bunch of resources, right? There are some action items that are coming out of this, right? So we need to actually get Minecraft Bedrock to work on Mac. So I'm going to work on that. And then next week we'll be back. I'm hoping for next week's around the same time. So let me fix that. I'm going to basically run virtualization on my Mac. And I'll run a Windows machine, I guess. But, and then we need to clean up firewall rules. So we need something for that. We need to get our add user function to work, which this might not all happen in one video, right? But I think those are a good baseline things to start with. And then we can look into like expanding on other things like automated backups of our Minecraft server, for example, or actually monitoring our Minecraft server, shipping logs to locations. And this is just, maybe we can even do like single sign-on for authentication, so you don't have to use those functions at all anymore. You just have an authorized users list, and that's how it works, right? So maybe we'll look into like using a free tier of Okta and integrating Okta with our simple Minecraft server, right? But The reason I wanted to show you guys this is so we can kind of like expand on it. And this is kind of how development works in the cloud, essentially. Like if you're a DevOps engineer or anything like that, a lot of times it's like, all right, we have the functioning product out, and now we can iterate on top of it. Any type of software development, I would think, works like that, right? So you don't ship a finished product ever. You ship an MVP, enough to get stuff working, and then you build on top of it in order to make it this well polished machine and super reliable and all this other stuff, right? So this was a beginning step on doing this. Again, we'll be back probably next week. Let me figure out some things with stupid Mac stuff. Anyway, that being said, guys, thank you very much. Link to all the code is going to be in the description after this video is over. I can't update the description right now, but it'll be there by the time you're watching this if you're watching it on the replay. So give me a like, leave me a comment. If you have any suggestions for my add user function, the IPv6 problem, if you're a guru on that stuff, let me know. Or we're just going to basically turn it into Python and use that. But I digress. Thank you guys for watching. You guys have a good night. I will see you guys next week.